Up to 40 kilowatt hours of energy is required at this site every day. We're going to show you what it took to design this off-grid system for the Woodford Waste facility. This remote site has got a suite of Victron products installed. Let's go check it out. G'day, I'm Eddie Springer from Springer's Solar. Today we're going to showcase the Woodford Waste facility. Now this was a newly constructed facility as part of the dump site out at Woodford, and we received a brief of tender documents from the engineer outlining their requirements for an off-grid system. So we had the gate facility with air conditioning, hot water system, fridges, site room, lunchroom. We also had the weighbridge, and then also the security, the ground lighting, and the general power requirements for the whole facility out at Woodford. So this is a standalone power system, not connected to the grid, and it was chosen because this site's location is a bit remote. It's out of the way at the back of Woodford, and they wanted to utilise a standalone power system with generator, solar, latest technology batteries, latest technology Victron equipment to be able to power this facility night and day, 365 days of the year. This is a containerised standalone power system. So we've supplied a 20-foot container housing all our electrical equipment, batteries, solar controllers, solar inverter, and then we've done our solar system on a ground mount frame. The brief from the engineer was that the site was to have 60 kilowatt hours of energy storage and a 30 kilowatt solar array, and it was to be a 3-phase, 10 kilowatt per phase energy system. We designed our system around this, and the easiest solution for us at the time of this installation was to utilise the Victron equipment. We were able to keep the same product across a number of different facets of this installation to allow the system to work seamlessly together. Firstly, let's talk about the solar system at this property. There's not a lot of roof structure out here. We've got the small site shed and the weighbridge station. So the client opted for a ground mount solar system. So the system is on a racking system installed on the ground. Now this posed a hell of a lot of challenges because this site is a fill site. We've got capping over landfill. So our engineers and the site engineers didn't want us digging up a lot of the ground. They didn't want us installing large strip footings or large concrete footings at this site. The fill underneath and the landfill underneath would have been compromised. So we opted for a Surefoot system, which allows us to drive piles on a small pad footing into the ground to ensure the solar system can then be installed on top of that. Now, being a fill site meant that the Surefoot system that we used required a lot of piles per footing. So more than we would normally use, of about 4 to 6. This site had up to 9 piles per footing. But the pile driving was pretty easy. We utilised a large jackhammer with a specific attachment to drive those piles into the ground. And we laid out our ground mount system, laid out all the piles, did our set out, and then spent a couple of days driving those piles into the ground to allow us to then interface the Clenergy ground mount system on top. We had 2 rows of panels here, ensuring the panels are kept away from each other to avoid shading, but this allowed us to capture a perfect angle for the solar system and really utilise that northern exposure to the sun. So being a large ground mount system, we need to ensure that we restrict access to this as a requirement under the Australian standard. So we've installed a chain wire fence around the array with a padlock on the front that just keeps people away from the array and away from the container and generator. So it's a restricted access part of the site out at Woodford Waste facility. So we have 3 Victron multi-plus 10 kilowatt inverters. We also have 3 smart solar Victron MPPTs. So these are an RS450-200. We also have an RS450-100. And these MPPTs control the solar energy being generated from our ground mount system and the way that they charge our batteries. Now in this system we have BYD flex batteries, and these are coupled up to meet that 60 kilowatt hour target. We also have a Yanmar diesel generator, 30 kVA. It has an auto start function, which again couples into our Victron system. We program this system to ensure that that generator runs periodically for maintenance, but also we have preset state of charge parameters in the system to ensure that the generator runs as required, to make sure that the property manager out there never loses power. Now, this system being a 60 kilowatt hour total capacity battery system, it's good for about 2 or 3 days autonomy. So what that means is the site uses between 20 and 30 kilowatt hours a day, and we've got 60 kilowatt hours of energy storage. So even if the sun did not shine, the system will run for 3 days before needing to call up the generator. This is a robust, well-engineered solar system and a well-engineered electrical system to ensure that this site never goes down and is never without power. So with this containerized standalone power system, it allows us to pre-build the system back here at our facility at Launton. So our electricians and our team were able to line the container and insulate it. They're also able to pre-cable and pre-mount a lot of the equipment, get things ready for the installation out on site. You know, this reduces this time on site. We're away from our Launton office and allows us to really plan and test the system prior to delivering it to its final destination. So the installation went quite smoothly from our set out and our installation of the piles to our siting of the container on its concrete pad, our fencing contractor, everything went quite well. And, you know, pre-building the container here, a couple of guys in it for almost a week, on site for another week, and then commissioning and testing was a few days post-installation. We also had to liaise with the site IT team to ensure we got internet over to our facility so that we could get the data back from the site, and also interface with some of the other contractors on site to ensure that all trades were on the same page and that the system installation went smoothly. We didn't actually do the electrical work for the site, so running of the power to the site office or the rest of the facility. So we were working hand in hand with the electrical contractor on site to provide them with a connection point as if we were their Energex or their supplier. We provided that connection point for that electrical contractor then to power the facility. All right, this site's been installed for quite a few months now. So let's look at some of the data and see how it's performing. So with any Victron system, we're logging in through the Victron VRM portal and we stay on as a supervisor to the site so we can see the data and we can also help troubleshoot if we need to or change any parameters or programming as required. So general overview of this Woodford Waste facility is here on the front page. You know, it's 10 o'clock in the morning and we can see the battery state of charge is 92%. So we've almost recovered from our overnight usage and we're charging at a rate of about 9,000 watts. Okay, over on the right hand side here, we can see our different charge controllers. You know, 3 are listed there, but as we discussed before, there's multiple charge controllers on site. They're all the different MPPTs for each charge controller. And we're seeing how much energy they're putting in. But cumulatively, you know, 9,336 watts going into our batteries. And then our site load is here. So the site's currently using 1,500 watts. We can see each of the individual phases. So the site's quite balanced across L1, L2, L3. So 500, 600 and 400 watts being used out of the system. Site load's quite low. We are starting to come into winter. It's a milder day, so there's probably no air conditioning running, but we would see that load increase in summer with aircon usage in the shed and more power usage around the site. When we scroll down, we get to see our installation data. And this graph here is really good at showing us that the daily load is very consistent. You know, consumption across the board in here is around that 36 to 40 kilowatt hours. And our solar system, being the yellow, is just meeting that demand. You know, it's putting in enough solar energy to cover the usage each day. Tiny little green blip down here, a little bit of generator run time. What you'll find is that the generator actually didn't need to run on that day, but it's coming on with its periodic run cycle for a minimum of 20 or 30 minutes, and it'll be doing that once every month. This blue band we can see at the top, that's our battery state of charge. So if we hover over this again, we're seeing our battery is going to a minimum of 68% each day and a maximum of 100%. So we're seeing that battery minimum and maximum each day. So really, when we look at this, we spoke about the brief requiring 2 days autonomy. We'd get 3 days autonomy out of this system with not much sun because we're only using 30% of its capacity each day. We could do that over a number of days and we would be able to sustain the energy needs required for this site. In our advanced settings, we can go further into the data. We can add as many different widgets as we want in here, but this is just looking at the energy yield from each of the solar regulators over the last 30 days. We're also looking at AC output power from the inverter system. So all of the data across a number of different devices can be mapped and plotted to see if we need to tweak the system or see if there's going to be any problems at this site. But really, this is, like I said at the start, a robust electrical system, an oversized design that just means it works seamlessly, day in and day out. You know, batteries are charged by 10, 11 o'clock during the day. Even in overcast weather, we've got enough solar to get that energy back in, and the system sustains the load quite easily. So as you can see, a well-designed standalone power system means seamless energy provided, free from the sun, backup generator, transparent, easy to understand information. So if you're looking for an off-grid or standalone power system, please reach out to the experts, talk to us at Springers Solar. Thanks heaps for your time.